you can take a straight up AC measurement in here. You want to be super careful. Please use gloves and eye protection. And now we have a measurement. Hey folks, how's it going? For those of you that are new to the channel, my name is Luke, and today we're going to be going over all of the different test settings on your MM320 by Klein tools. It also came in a kit with some other accessories. I'll be going over those towards the end of the video, but we're going to hit every single test setting. I'll do a practical example here on the test bench of how to safely perform those tests and kind of what they're for to give you an idea. Unfortunately, I can't test every single different thing that you guys are going to be running into, so it's going to be kind of a general knowledge to give you an idea to apply to your own particular situation. I will say I've had these Klein meters on the show before, and historically they have performed pretty poorly given their cost, which is unfortunate because I'm a huge fan of Klein tools, but every time I have these meters on the show, they don't do that well. And for those of you that don't know how the show works, I'm gonna test and use this meter for the first time. I turn on the camera and I just go through every different setting. So I don't know yet if it's a good meter or not. So we're gonna have to basically just watch and find out together. Hopefully it's good, but you never know. Sometimes meters break halfway through the show. Sometimes a fuse blows. Sometimes half the settings don't work. And just because I could have a defective meter doesn't necessarily mean that all of them are defective or that yours is defective. It's just the one that I bought. It's one sample out of a lot of them. So if yours is or isn't experiencing the same symptoms, let us know down in the comments. Let's try to get everyone informed and a bigger sample size on if the test settings are all working properly for everyone or if potentially there's a problem with quality control. So with all that being said, why don't you grab a snack, have a seat, let's dive into it. And when you get a chance, check out some of the links in the description below. All right, folks, so I'm sure that you've noticed that there's just a ton of different settings on here, and it can be a little overwhelming and confusing. And that's okay. That's what we're here to help break down, is how to use a manually ranging multimeter. So before we get into it, there's a couple things that I want you to think about or have a mindset with when you're utilizing a meter like this. So what do we have going on here? Well, we have the dial, this main dial here, is broken into different sections for us. And what it's trying to say here is, okay, this is for measuring volts AC. That's what that little squiggly line is to indicate. It's supposed to represent a sine wave, and this is volts AC. So like AC voltage is gonna be like out of the wall socket, as opposed to DC with the straight and dashed line here. Think of that, batteries. So we can measure volts AC. We can measure the stuff coming out of the wall socket with this setting. And then there's a 600 and a 200. The numbers, I want you to think of the numbers as this setting can measure up to 200 volts AC. That's what that setting is trying to tell you. And then the 600 is trying to tell you you can measure up to 600 volts AC. Okay, so why would they have two different settings? If the 600 one can measure 200 volts AC or more, why wouldn't we just use the 600 setting? Why is there a 200 setting there as well? I want you to think about kind of like using a microscope. When we use a microscope, we've got that lens, you know, chilling way back here, and then we dial it in and get closer to give us resolution in our image. When the lens is way back here, we can see stuff going on. It's not very clear. We can tell there's an outlet. We can tell there's a meter, my iPod's case. But when we bring in the resolution, we can see a lot clearer and a lot finer detail. It's going to be the same mentality with our different settings here and why there's so many of them. So for our volts AC, we're going to start on the 600, and I'm going to measure a 120 volt source. But if I bring it down to up to 200, then I'll be able to read to the tenths of that. Now, it's not that big of a deal for AC and these larger voltages. That's why there's only two settings. But when we start to get into DC voltage or into our resistance values, it's going to be really important. to have a better understanding of those settings. And we're gonna do a ton of examples of it. So if it's a little unclear right now, by the end of the video, you should fully understand all of these settings, why it's like this, and how it works. Okay, so let's go ahead and get started into our first measurement. Now, this kit does come with a outlet tester. Things like this aren't bulletproof. They're just to give you an idea if there's voltage and if it's wired correctly, because Lord knows who wired the house. So whenever checking an outlet though, I do prefer this because it's so much easier to use. Let's get this thing hot. A little unsure about that at first. Okay, so then it has, it tells us, what's it gonna say? Open ground, open neutral, open hot, hot ground reversed, hot neutral reversed, or correct wiring. And we can see that it's correct here. That's the way that I prefer it. But if you're gonna use a meter, which you might, because you might lose this, I don't know. Or maybe you're feeling risky, you can take a straight up AC measurement in here. You wanna be super careful. Please use gloves and eye protection. And now we have a measurement. I am on the 600 volts AC setting, and we can see it's showing 122 volts. If I measure up to 200 volts, we're gonna see that finer resolution come into play, and now we have to the tenths place. So it's not just 122 volts, it's 122.6 volts. It's also indicating that it's AC, and this little lightning bolt is telling you, hey, this is a live, powerful circuit. Please be careful. That's how that works. We're gonna do diode next, and then we'll do more of the resolution and the numbers and all that stuff when we get to ohms over here. And then if you are just testing an outlet with just your meter and you don't have your little outlet tester thingy handy, how do you figure out ground, neutral? Let's just knock that out while we're here. So this is a live outlet. We have a hot and a neutral. Some people will say, oh, it's a hot and the neutral because one's bigger than the other. Don't ever assume that. That's a good way to get barbecued because you don't know who wired it. You don't know if it's correct. So the way that we can tell is we're gonna go off of finding the ground and the neutral and the hot. So right now I have a difference of potential. So I have one hot and either a neutral or a ground. And then I can swap to my ground prong here. I don't like doing like this because you just don't know if you're getting good contact. But right now, I'm showing 1.3 volts. Okay, so there's very little difference in potential. That's telling me that I'm probably going between my ground and my neutral. So I can now swap. Okay, and I have 122.6 from here to here. And I'm gonna have the same from here to here. So that's telling me this is my hot, this is my neutral, and that's my ground. And that's the way you kind of discern who's who out of everybody when you're checking it. I don't like doing it like this because you can spread the prongs in the outlet. It'd be much better to get to the contacts on the side, or better yet, with an outlet tester. But if you need to, that's the way that you can go about doing that. So let's get some diodes going. These are just standard little diodes, and notice this little silver stripe on here, and that's to indicate direction. We're going to always measure our diodes in both directions. I'll get to the lead ports a little bit later. I know you're curious about that, but common. This red one will hang out in this port 99% of the time. When we test a diode, we'll test it in both directions because if you're not too familiar with diodes, they're basically a one-way check valve for electricity. The first way we're gonna measure it is gonna be like this. This is where this hold button will come into play. Now I can take my leads off. And we're getting a number here, 0.540. I really like that they have the decimal there because that's trying to indicate to you that this is a fraction or a decimal of a voltage and not full voltage. A lot of times they won't have a decimal there to just show a whole number, and you'll think, wow, 540 volts, I guess is what we're reading off this diode, if you don't know. So they have this decimal here. What you're really reading is 540 millivolts or 0.54 volts, okay? A voltage drop across our diode, and we want to see between 500 and 800 millivolts of voltage drop across our diode in one direction, and then in the other direction, we're going to want to see that OL. And that OL is for open loop or out of limits, depending on the context of the measurement that you're making. But basically, it's just saying there's no flow in the other direction. So this one tests good. And then I always like to check to see if they can light a white LED as a little extra test in the diode setting. And it cannot. Not a big deal. Who cares? I'm the only person, I'm pretty sure, keeping track of which meters on the market can light a white LED. But that's neither here nor there. So next up, we're going to get to our resistive settings. And these are super handy. Our continuity and our resistive settings. That's what the little speaker's for. Since that's next, we're going to go ahead and hop to that one. And what it's going to do is omit a tone when there's flow. And a way that you can check it is you can just take your leads and we should get a nice stable tone, even when you move your leads around like that. Really good sign. I'm liking this meter a lot so far. It's passing all of the tests. Continuity, what is it good for? Absolutely nothing. That's not true. It's good for sorting out who's who. So if you got a couple of wires, say we're in a scenario, we got two wires, we got two terminals. We don't know which wire goes to which terminal. You can just use your continuity setting. Oh, I've got a tone. So that means this black wire goes to this terminal, and then we can verify red wire to that terminal. I know it's kind of simple with just two wires, but when you're dealing with a bunch of wires or like automotive wiring or something like that, it can be a very handy setting to have. And then there should also be, along with that, a resistive value. Right, it's showing 0.6 ohms, 0.5 ohms. That's a very small amount of resistance across our circuit, indicating that there's good continuity. So let's hop into the rest of this setting because it's kind of confusing because we got the continuity setting and then we got a whole bunch of other numbers going on here. And we're going to want to understand this K and this M because we're in the metric system and all the meters are set up like this. So it is nice because no matter what meter you pick up, you're going to know it's in the metric system and these symbols are all going to mean the same thing. But for us here in the US, it can be a little bit confusing because we're not very comfortable with the metric system and neither am I. I had to learn all this just to learn how to do meters. So, okay, so we have the M and the K. So M is going to be for mega or think of million. So this setting can measure up to 2 million ohms. It can measure everything below that, but it caps out at 2 million. And then under that, we have 200K, the K for kilo or thousand, right? So 200,000 ohms, 20,000, and 2,000. So it can measure up to those ratings. And think of this as the resolution dial of what we're trying to measure for our ohms. When dealing with a manual ranging meter, if we don't know what the value is going to be, which we probably don't, that's why we're using a meter in the first place, I always like to start big. If I'm going to take a resistive measurement, I got no clue what it's going to be. I start at the biggest setting. So in this case, I'll start at the 2 mega ohm setting, and then I can just go ahead. These are just little resistors I have here. They're just in a fancy block for ease of doing videos. Okay, and now I've got a measurement. What is all this trying to say? 1.043 ohms. No, we got to pay attention to the M and the context of the setting that we're using. So this is 1 mega ohm or 1,043,000 ohms. We're gonna keep going through a bunch of examples in case it's not sticking quite yet. It gets easier, trust me. Okay, so we're at 1,043,000 ohms or 1.043 mega ohms of resistance. Take the hold button off. Let's just take another measurement of a random resistor. Okay, I'm in the 2 mega ohm setting. It's not showing OL. So even though it's a random resistor, even if it's all zeros, it's trying to tell me, look, I know there's resistance there. I just don't know how much. I don't have good enough resolution to tell you the value of that resistor, but there's something there. And this is where we can start to dial in that resolution, just like the microscope, when we start to bring things down into clarity. Same thing here. So I'm at 2M, I can go to 200K. Okay, so it's saying 1.0K ohms. So there's a chance that this resistor is probably around 1,000 ohms, but I have two other settings here that are higher than 1K ohm. So I know I can keep dialing down comfortably. So we can go to 20K ohm. Okay, now we're getting better resolution. It's not just 1,000 ohms. Now it's saying, well, it's really 980 ohms or 0.98 K ohms. So I can go down even further. I'm still in K ohms, so I still have a decimal point, but now I'm showing 983 ohms of resistance. And let's see if it'll do it on the next setting. Oh, no, it's not. I got an OL that's saying I'm out of limits. I know the proper setting for whatever I'm measuring. This is the best resolution that I have, and that's the most accurate number that I'm gonna get, 983 ohms or 0.983 kilo ohms of resistance. And then let's just do one more. Okay, so again, we're showing zeros, not an OL, so we know there's some type of resistance there. And I can just start walking down the dial now that I have a better understanding of the concept of what's going on here and just dial it into resolution. Oh, it's probably gonna be about 70 ohms is what that's trying to say. Okay, 68 ohms. Okay, and now this is the most accurate that we have. It's really 68.5 ohms once we dialed it in. And we're gonna keep going. We're gonna beat this dead horse into the ground, okay? All right, next setting. This is gonna be for current. I wish there was a line divide here because this is where you're gonna have to start paying attention to your lead ports. And I'm sure you noticed there's two fuses back here when you put your batteries in. That's what's going on here. So let's take these leads out so we can get a better idea of what's going on. With current, we can have the same rule of thumb as we did with resistance. We can always start with the biggest one. And this is saying 10 amps of DC current, right? Because DC is the straight and dash line. It's not rated to measure AC current. So everything that we're going to be doing is going to be basically battery powered. You can't measure current coming out of the wall with this. So this is saying I can measure up to 10 amps of current. The problem that we have is in our normal little slot right here, we're only rated for 200 milliamps of current before this fuse will blow. But this port has a 10 amp fuse. For this setting, this is the only setting where we're gonna move this red lead from here over to here to measure our current. So the black lead will always stay in the common port. And then our red lead for this test, we're gonna do into the 10 amp port. And then notice we have 200 milliamps, 20 milliamps, and 200, that funky U right there is for microamps. It's an incredibly small amount of current. 200 microamps for very, very tiny measurements, 10 amps for much bigger ones. Another difference that we're gonna do here is we're gonna use the meter as a jumper wire to complete our circuit. And that'll make sense here in a second because for current measurements, we have to do it in series as opposed to all the measurements we've been making now have been in parallel. But in series, we're gonna use, because of the way that the meter is configured right now, we're gonna use these wires to complete our circuit. So notice we've got, this is our power side, and this is our load side. And for our load, we have a light bulb, and then we haven't completed the circuit yet, right? There's obviously something missing right here, and that's where our multimeter leads are gonna come into play. And so we're gonna use the leads to complete the circuit and light the bulb. Okay, so that's great. Then we can press the hold button, and then we can explain what's going on here. So it's saying, hey, you just measured 2 amps of DC current. 2 amps. Now 2 amps is much bigger than 200 milliamps. 200 milli is very small. We use the appropriate setting. So it's always good to start big and then work your way small. Let's try another load here, just as another example, see what it comes back as. Give us another unit of measurement to work with. I think current measurements are really fun, just because I'm obviously such a fun guy. But I think that they're fun because The amount of current that an electrical load can use is probably a lot different than you would think. Like, okay, so I have this DC motor here. What's your guess compared to that light bulb? How much current it's gonna use? Just try to think about it. Probably you would think more, right? You would think more current. But if we take a measurement, considerably less. This is saying 0.44 amps of DC current, or we can think of it as 440 per 10 0 right here, because we got a decimal, 440 milliamps of current going on right there. One last thing I want to explain before we dive into this more. If you're making current measurements or voltage measurements and you're getting a negative sign to the left-hand side of your measurement, see there? That means the polarity of your leads is just flipped from what the meter is expecting. So for DC measurements and current measurements, the polarity, which lead goes onto which terminal, will matter because it'll give you a negative sign. So just a heads up in case you see it, don't want you to get confused. Let's take a normal measurement again and kind of talk about, okay, so we're at 400 milliamps of current draw for this motor. We started big, we're still on the 10 amp setting, but it's really small. I'd like to get more detail for this, but we need to think about the next setting down is for a maximum of 200 milliamps. So if we were to switch our port back over to here and move this dial to here and take a 400 milliamp reading, but our fuse is only rated for 200 milliamps, there's a chance that we'll blow that fuse. So we need to be cognizant of that. We also need to be cognizant that in this mode, because this is essentially a jumper wire, you can start to short things out. And that's another way that you can blow the fuse in here, or you can damage components of whatever you're trying to measure. So we need to keep that in mind. When we start to measure current, things start to get a little bit hairy. We want to start to be really cautious. I would probably buy some extra fuses. I've got some fuses in my Amazon store. I don't know if I have fuses for this meter. I'll try to get some of those in there. Link in the description. Let's do a couple more current measurements. All right, back to these resistors. These resistors make really great small, you can read small amount of currents really easily with little resistors like this. So we'll get a power source fired up and we're gonna keep it on our up to 10 amp setting. I'll keep it, my red port over here all the way hanging to the left, and we'll just start making some current measurements and see what we get. Okay, so I'm getting on this one, I'm getting 30 milliamps. So that's incredibly small. So that tells me, okay, everything here that I'm trying to measure is gonna be well under 200 milliamps of current. So I can now safely move my red lead back over, and then I can go to my next setting down. Can you see why I would kind of have wanted them to put a little line here, some kind of notation to the user, let them know, hey, if you're gonna use the 10 amp setting, you gotta switch your leads over, and then to use the next setting down, you gotta move it back. There's no indication of that here, so it can be really confusing, especially if you're learning. Now we've got it on a 200 milliamp setting, and it's gonna be the same thing as the microscope. The 200 milliamp setting relative to these other two is a big number. And then we can work the dial down into focus, right? So that's kind of the mindset. So we can measure up to, and great, they even got a little M right here to let us know, hey, you're reading 36.9 milliamps of current. 37 is still bigger than the next setting down, which is 20 milliamps. So that's the best resolution I'll be able to get for that measurement. So then let's try the next one over. Okay, it's at 12 milliamps. 12 is smaller than 20. So I technically can go to the next setting down and I'll be able to read to the hundreds place instead of just the tenths. And there we go. It's saying 12.25 milliamps of current is being read. So I'll go on to the next one. So I'll start it big again. Next one down. Okay, now we're getting really small. 1.1 milliamps. That is smaller than 20. Still bigger than 200 microamps, though. That is very, very small. So we'll leave it there for now. Let's see what this is. Okay, so this is 0.11 milliamps, or you can think of it as 110 microamps, which is smaller than our 200 microamp setting. So we can comfortably know that we can go down to there. And this is showing, hey, you're measuring 121 microamps of DC current. Pretty cool, pretty small, very small amount of current. All right, next up, we got some fun stuff going on here. We have our 9 and 1.5 volt battery settings. Very cool, very straightforward. Red to positive, black to negative, 9.4 volts DC battery. And what this does is it puts a little bit of a load on the battery, kind of like a voltage drop. So I don't know if you've ever used one of these little battery testers. These battery testers put a load on the battery to let you know if it's bad or good. Yeah, what's going on there? There we go. This one's good. Puts a little load on it. Same thing with your meter. 1.5 volt. Boom. There you go. Okay, and then lastly, we have volts DC. I think we should all feel, after going through everything else here, this should look pretty straightforward and we should feel pretty comfortable by the time that we've gotten to here. We should be able to know, okay, we can read up to 600 volts DC all the way down to 200 millivolts DC, and we can anticipate how all the different settings work. So now if we think, okay, I've got a 9 volt battery. I know batteries are DC and I know it's 9, so it's going to have hopefully at least 9 volts of potential in it. Then I can think, okay, if I'm about to measure something that I know that's going to have at least 9 volts, I'm going to want it to be more than 2. And I could probably use the 20 volt setting, and that should give me the best resolution measurement at 9.48 volts DC. We did the hold, we did the leads, we did all the good stuff. I will say this meter is honestly not bad. I'd say incredibly overpriced. There is no capacitance measurement, which you're going to want to need to be testing your AC unit. But I'd say outside of that, I think it's got pretty much everything you would need to get you started. Let's quickly go over the other accessories in the kit in case you have those and are curious about what they're for. We briefly covered the outlet tester and outlet testing. So then really all we have is your hot stick and your batteryless voltage tester. I'm a huge fan of these. I think they're super underrated. It really doesn't even matter. Doesn't even matter to me what you're trying to measure. Yeah, those leads are small. You're probably not gonna be able to fit that. Okay, let's see how this bad boy looks. Great. Okay, so this is saying you're right at 120 volts. It doesn't tell you if it's AC or DC, but it's just saying voltage is present and approximately how much. And for most people, that's really all you need for the most part. And then for your hot stick, please be careful with these. They can give you false positives and false negatives. NCV stands for non-contact voltage. We also have 12 to 1,000 volts AC or 70 to 1,000 volts AC, depending on how sensitive you would like it to be. No beeping sound? Oh, dude, that is weak. No beeping sound on the hot stick, just a light. Well, that's kind of disappointing. Man, all the way up until the end, they were doing so good. But there it is. Let me know. I've got a bunch of stuff on the channel about different electrical concepts, how to test different things. I really recommend going and check it out. If you don't have this meter, if you got one like it, I've probably got it on the show. I've probably got an example of what you're trying to test on the show and how to test it. Let me know your questions, comments, or concerns down below. Go ahead and check out the links. And thank you for joining me. I'll catch you on the next one.